All right, welcome to this explainer. Today, we are cutting straight through the noise to uncover the top 5 AI tools that mechanical engineers are actually using in 2026. We are literally standing at this wild intersection of traditional mechanics and futuristic intelligence. So let's look past the flashy marketing brochures to visualize the real systems, the glowing AI interfaces, and digital blueprints that are genuinely transforming automated workflows on the factory floor. So let's dive into this big question right off the bat. Is it ready? Because AI has rapidly shifted from a mere science experiment to a daily driver in high-tech smart factories and engineering bays. It's crazy to think about, but just 2 years ago, the conversation was whether artificial intelligence even belonged in engineering at all. Now, well, the question isn't if, but which tools? Which ones are actually powering smart factories? And which are just, chasing the hype? Here is our digital blueprint for today. We'll quickly cover the AI engineering shift, unlocking hidden knowledge, designing the impossible, warp speed simulation, the generalist trap, and finally, how to build your ultimate toolkit.
Take a look at this. This perfectly captures the aesthetic of where we're heading. It's this incredible environment where robotic automation physically meets holographic digital blueprints, and artificial intelligence just layers over everything we do. It's not just about drawing parts anymore. It's about engineering the future through a really deep integration of technology and organizational knowledge.
Okay, Section 1, Unlocking Hidden Engineering Knowledge and Solving the Infamous Search Bottleneck. Let's talk about wasted time, because the highest volume of engineering hours just vanishes into the ether while we search for legacy data across disconnected networks. Look at this massive number, 1 million. That is the number of industry standards, engineering textbooks, and technical references that a tool called Leo AI is trained on. Leo AI has emerged as an absolute leader in knowledge management because it tackles the exact problem that wastes our time, finding information that isn't sitting on Google, but is buried deep inside your company's proprietary systems. Now, instead of replacing your systems, Leo AI acts like this glowing intelligence layer that perfectly integrates into major platforms. Whether you're running SolidWorks PDM, Siemens Teamcenter, or your company's custom ERP systems, it just plugs right in. And crucially, this is huge, it does all this while keeping your proprietary IP totally secure. They are SOC 2 certified, GDPR compliant, and your highly sensitive data is absolutely never used to train their AI models. So here's where it gets really sci-fi. You can literally upload a 3D CAD file, and the AI scans your entire database for geometric matches. Or you can just describe a part in plain English, and the system executes a text-to-CAD search, pulling up the exact physical geometry you need from the absolute depths of your network drives. It is a massive leap forward for part reuse. I love this quote because when product engineers on the actual factory floor are telling you that a specialized tool is beating out massive generalist models like Perplexity, specifically because it understands CAD context and provides source citations from their own data, well, you're looking at a true paradigm shift that changes how you work every single day. Moving on to Section 2, Designing the Impossible, generative design that engineers can actually control. Let's look at how this builds our workflow by comparing two absolute heavyweights in generative design. This really highlights how specialized things have become. On one side, we've got end topology, which pushes the absolute limits of additive manufacturing with implicit modeling. It lets you create these mind-bendingly complex lattice structures you could never model by hand. On the flip side is Altair, which excels at applying real-world physics constraints. It takes your load cases, factors in material limits, and generates highly optimized topology. They are both brilliant, but they are highly, highly specialized. Then we have Practical, everyday CAD automation from Autodesk. It delivers fantastic practical features, like intelligent component recognition and automated drawing annotations that actually learn from your modeling patterns. But, and this is a pretty big but, there's a catch. It requires total lock-in to their specific ecosystem. So if your team relies on Creo, NX, or SolidWorks, you're pretty much locked out of the party. All right, Section 3, Simulating at Warp Speed, taking things from hours down to seconds. Because honestly, what good is a rapidly generated design if it takes 3 days just to test it? Setting up a proper FEA study is such a massive time sink. Enter ANSYS Semi-I. It replaces hours of traditional FEA solving with near-instant machine learning predictions, letting us rapidly iterate on early-stage concepts. Now, it's not completely replacing the final high-fidelity simulation, but it absolutely allows you to explore dozens of concepts and get immediate physics predictions before committing to a full solve. Looking at this chart, seeing processing time drop from hours down to mere seconds, that's literally every engineer's dream. But actually, let's do a quick reality check here. ANSYS is expensive, it carries a very steep learning curve, and the AI features require massive data sets of your prior simulation results just to train the predictive models. So, if you're a smaller team running occasional simulations, you're probably not going to see this massive drop-off. Which brings us to a super important warning in Section 4, the generalist trap. We're talking ChatGPT and Claude in engineering. Look, general chatbots like ChatGPT or Claude, they're fantastic for brainstorming or sanity-checking a heat transfer approach, but they are fundamentally dangerous as a source of truth for engineering. General-purpose AI has zero connection to your company's actual data. It doesn't know your design history, and frankly, it will hallucinate technical details. Engineering-grade AI, on the other hand, is rigorously connected to your internal PLM, it displays its mathematical logic, and it rigorously protects your proprietary data. Okay, Section 5, Building Your Toolkit. Let's talk pragmatic steps for 2026. Since no single AI tool covers the entire mechanical engineering spectrum, building your toolkit requires a really surgical approach to solve specific problems. Step 1, identify your specific time bottlenecks. Are you losing time just searching for parts? Well, that's a job for Leo AI. Is it simulation throughput? You'll want to look at ANSYS. Step 2 is selecting and deploying those targeted tools. And step 3, absolutely crucial, is ensuring absolute IP security and data transparency. If there is one ultimate, undeniable takeaway from all of this, it's this right here. In our field, transparency and verifiable logic are totally non-negotiable. The AI said so? Yeah, that is never an acceptable justification. If an AI gives you a calculation or a part recommendation, it literally must show you the exact math, the source document, and the context. The best tools understand this fundamental rule of engineering, and they always show their work. The technology is officially here. The advanced interfaces, the generative workflows, they're completely real. But success in 2026 comes down to strategy. So take a hard look at your current factory floor. Are you surgically deploying the right tools for your specific bottlenecks, or are you just blindly chasing the neon hype? Think about it. Thanks for watching this explainer, and keep engineering the future.